In this video, I'm going to be talking about the arc length and sector area of a circle. I have with me a circle which I have drawn here, and we have the R, which is the radius. This is the radius, and this whole part here is called a sector. And then from this point to this point right there is what is known as the arc length. We have an angle right here known as theta. The smaller sector of an arc is known as the minor sector, or the arc, is what we have right here. The larger sector or arc is known as the major, and we're talking about this whole part right there. To find the arc length, which can be denoted by L, we say theta over 360 times 2 pi r. We can also find the sector area, which is denoted by A as theta over 360 times pi r squared. We take a fraction of the whole circumference depending on the angle at the center of the circle. The angle that we'll be having right here is what we are talking about. I'm going to go ahead and give you a few examples so that you truly understand how to go about the arc length and the sector area of a circle. Example number 1. We are asked to find the arc length and sector area when r is equal to 4 and theta is equal to 30 degrees. To find the arc length L, we say theta over 360 times 2 pi r, and we get our theta is 30 over 360 times 2 pi, and our r is 4. And if we calculate this, we get 2.09, correct to 2 decimal places, and these are in centimeters. To get the sector area, we say theta over 360 times pi r squared. Our theta is 30 over 360 times pi, and our r is 4 squared. Hence, our answer would be 4.19 square centimeters, and this is correct to 2 decimal places. Moving on to number 2, we have been given a diagram as the one I've drawn below, and we're told the parameters OA is equal to 2 centimeters, OB, which is OB, is equal to 3 centimeters, OC, which is OC, is equal to 5 centimeters, and OD is equal to 3 centimeters. For all these sides, we are given the angles, and I'm going to rewrite this. So OA, our radius for OA is 2 centimeters, and our theta is equal to 60 degrees. OB, R is 3 centimeters, and theta is 120 degrees. For OC, our R is equal to 5 centimeters, and our theta is 45 degrees. OD, R is equal to 3 centimeters. And then for theta, we have 60, 120, and 45, and we don't have an angle here, which is what we want to find. The angles right here add up to 360. So for us to get the angle, we're going to say 360 minus 60 plus 120 plus 45, and we get our theta as 135 degrees. By the way, I forgot to write what we're finding. We're finding the area, and this area is the total sector area. I'm going to start by finding the area of OA, and that is going to be 60 over 360 times pi. My r is 2, so that is times 2 squared, and from this we get 2 over 3 pi. And then moving on to finding the area of OB, that is 120 over 360 times pi times 3 squared. And the answer that we get there is 3 pi. And then area of OC, that is 45 over 360 times pi times 5 squared. And we get 3 and an eighth pi. And then area of OD, that is 135 over 360 times pi times 3 squared, and we get the answer as 3 and 3 over 8 pi. Now, the total area is going to be found by adding all these four numbers, 1, 2, 3, and 4. So, the total area is equal to 2 over 3 pi plus 3 pi plus 3 and an eighth pi plus 3 and 3/8 pi. And we get the total now, rounding it off to one decimal place, that is 31.9 square centimeters. Moving on to number 3. In this example, we're given this shape as I've drawn right here, and we're asked to find the area shaded. Already by looking at this, I can tell that this is a quarter, and also by this angle that we're given, this is a quarter of a full circle. So in whatever formula I'm going to use 1 over 4 multiplied by the formula. So to get the shaded area, in this case, we're going to say a quarter times pi, the radius is 5 centimeters. Hence, that's quarter times pi times 5 squared, which gives us 19.634. The radius from this point right there, for this part right there, is 4 centimeters. So I'll then say a quarter times pi times 4 squared. You get 12.566. The area shaded is going to be 19.634 minus 12.566, and we get 7.0676. And rounding it off to two decimal places, we are going to get 7.07 square centimeters. That is the area that we are looking for, and it's the area of this shaded part. Moving on to example number 5. In this example, we're given a diagram as shown below, and we're asked to find the shaded area. I can tell that this is a sector, so I'm going to use the sector area formula. 40, since the angle is 40 over 360 times pi r. So I'm going to start off with the larger radius. So, because to find the shaded area, we're going to say this larger radius minus this lesser radius. Hence, we're going to say 40 over 360 times pi times 9 squared. This is going to subtract the smaller radius, that's 40 over 360 times pi times 5 squared. We get 9 pi minus 2 and 7 over 9 pi. I've kept it as a fraction like this so that my answer would be more exact. We get the answer as 19.5 square centimeters. That is the area of the shaded region. Moving on to the last example, which is example number 6. We are given a diagram below, and the question says the length of the minor arc AB, center O, is 2 pi centimeters. That means this is 2 pi centimeters. And the length of the major arc is 22 pi. So we have 22 pi. Find the radius of the circle and find the acute angle AOB. The circumference of the circle is 2 pi plus 22 pi, and we get 24 pi. That is the circumference of the circle. To find the circumference, we use the formula 2 pi r. And our C is given as 24 pi is equal to 2 pi and r, and want to find r. So to find r, we then say 24 pi divided by 2 pi, and we get 12 centimeters as our radius. To find the acute angle, remember we've been told that the minor arc length is actually 2 pi, and we know that the arc length L is equal to r theta, when theta is the angle in radians. Therefore, for the minor arc AB, we say 2 pi, which is our length, is equal to r theta. 2 pi is equal to our r, that's the radius that we just got, so that is 12 theta. For us to get theta, we say 2 pi divided by 12. We get our answer as pi over 6. But take note, this pi over 6 is in radians. And for us to change from radians to degrees, we multiply by 180 over pi. Hence, the angle would be pi over 6 times 180 over pi. This and this cancel. 6 into 6, 1. 6 into 180 is 30. Therefore, our theta is equal to 30 degrees. So the acute angle A or B is equal to 30 degrees. That is it, guys. Take some time to practice these questions even further, and do hit the subscribe button. I will see you in the next video.